remote online. So it's a little bit distributed, the people who are joining the WESAC this year.
So I would have been here over there, you know, guys. And then I tried to check for the money for local funding, but then I would have problem for other travel. So finally, but really, it would have been amazing to be over there and discuss with you. But so you say that partially it is in presence, and some part of the people are also online.
Okay. Yes. We are running the hybrid mode of the conference. Yeah. You are not the only one that is remote. Other lectures are being remote.
Okay, I see.
Yes. Funding is being a little bit challenging to get nowadays.
Yeah, I can understand. I'm trying to change to move. Okay. Where these and then these here. Okay. Just.
Hello, Alessandro. Welcome to WESAC.
Hello. Thank you. Hi. Fine.
Just a few minutes. People are coming. I guess they maybe go late to home yesterday.
Yeah, but you know, I can understand perfectly.
It's typical in conference. I don't know.
Yeah. How's it going? So, is it going? I mean, how's it going, WESAC? So, do you have? Are you satisfied with the conference?
Yeah, it's a bit challenging to make a kind of hybrid conference, part in person, part remote. But the works and the lectures are very fine, very good. Alessandro, can you try to share your presentation? You have slides, I guess.
So, in fact, just because I was trying to have the two. So I should share the screen, right? So sharing.
Or share the screen, or there is one plus button near to left bottom corner. Yeah. Where you can add presentation or share presentation, so you can upload the PDF.
I see. So I can share, but because I see manage presentation, start a poll, share an external video, share Google Drive, layout setting. So you mean manage presentations?
Yes, I guess so in English, because I use it here in Portuguese.
Okay, yeah, and I see that I can upload. Okay.
Yes.
I see it. So let me check the last version of the presentation so that I'm sure about that. Okay, replace. Oops. Because I need to share using PDF, right? I'll probably print each stage of the bit, right? This one. Okay. So I'm going to then load this file. I can close this. I can conference this. To be uploaded. Okay,
I cannot see yet. Let me see now my screen.
I have to press upload. Yes, now it's uploading, right? And then, so can I manage the switch of the slides, or?
Yes, everything.
Right? So, okay.
It must be loading yet. All right, I can see already.
I see. So you mean that I can move on the slides directly from
Perfect. Yes.
Okay. Great. So I don't need to have I don't need to have the double screen because everything is then I see. Good. So I switch off. Right. Good.
It's fine.
Good. I hope, guys, that the presentation could be a little bit interesting. I'm not sure about that because I don't know if at the end there will be something about more also related to the next version that is going to be there for Carthago, but I'm not sure that it is so interesting. Anyway, this is the presentation.
We're just waiting some okay from Michael also, and then we can start.
By the way, Michael, how are you?
I'm doing fine.
Now,
yes.
Yeah, but
long time that we don't see each other.
Yeah.
Actually.
So at the end of the day, you got you got a position. You are able to inspire. That's great.
Yes, we work together. Me, Michael, Jomi. Michael works in the same university, but in Blumenau, other city. Me and Jomi work in Florianopolis.
Right, I remember that. Yeah.
Yes, just different departments, but the same university.
Nice. I'm so happy.
And how is everything going? University of Bologna. I guess Angelo is working there, right?
Well, he left. He left in the sense that there was a huge important occasion that was about, entering as the main people deciding the digital transformation for the local health organization. We are working a lot in cooperation with them. And so we worked 4 years in order to, and then there was this, so he's going to be the man bridging also research and applications over there and trying to put forward also new directions for digital transformation about that. And so he's there, he's no more here. We get in touch continuously, but there will be a new PhD, I guess. I hope in few days. So we'll have also the possibility to go on.
All right. Just waiting yet. A couple of minutes.
Yeah, I don't have any. If we want to wait for someone, so I can see the people that should be there among the users, right?
No, most people participants are actually there in presence. Yeah.
I see.
So you're probably not going to see as many people here in our list online, I guess, because most of them are there online. Yeah, participants.
Yeah. Well, but for me, it's not a problem. Just to have, but maybe we are going to tell it after. Way off, interrupt me. So if it is possible to have a kind of interaction during the speech, the mumbling, the talk, I would be happier. Anyway, so just to have some kind of real-time feedback and questions and so on.
Michael and Alessandro, we are ready. You can start.
Okay. So I would like first of all to thank Professor Alessandro Ricci for accepting our invitation to come to WESAG remotely and to speak about some very interesting topics for our community. So the title of the presentation of Alessandro Ricci is Knowledge Level, Connectivity Architectures and Multi-Agent Oriented Programming, Revisiting Old Concepts for Envisioning New Directions, hopefully. For who doesn't know, Alessandro Ricci is an associate professor of DISI, Department of Computer Science and Engineering of University of Bologna. His research interests in general concerns agents and multi-agent systems as a paradigm for designing and developing software systems. In the context, main contributions in joint works with colleagues include Agents and Artifacts conceptual model, the Cartago platform, multi-agent oriented programming and the and the JaCaMo platform. He's currently a member of the IF-AMAS and EUR-AMAS board and part of the AMAS workshop steering committee. He's serving as program co-chair of AMAS 2023. So welcome, Alessandro Ricci, for the WESAG, and I let you conduct this presentation. I just let you all know, Professor Alessandro Ricci also said if you would like to interrupt him during the presentation, feel free to ask him questions and raise your hands in the chat so we can give you the word to asking questions at the real time. All right, Professor Alessandro Ricci, you are with the word.
Okay, thank you so much for the invitation. I mean, Michael and all the friends over there. I really would have liked to be there. And so to get in touch physically and so to discuss together. And so as this talk is going to be a kind of, let's say, a kind of, oh, I'm trying to see if it works, sorry. Okay, a vintage talk in the sense that, I mean, I'm getting back to something that really, in a way, it's quite personal, because I see that is something that I'm sharing about a strong interest. I hope that it will be, on my side, I hope that it will be interesting a little bit for also for you guys. So what's the point? So just to, as Michael said, if I have to, I mean, I worked on many things in the context of agents, multi-agent systems. I started from coordination, then I moved more on the programming languages and agent-oriented programming and multi-agent oriented programming. But then there was one point, sorry, I have still to get in touch with in all these idea, I mean, my background is not purely AI, but more software engineering. And for me, in software engineering, main concept was the level of abstraction that make it possible for me to design things, to develop things, to run things. And so for me, agent-oriented programming, multi-agent programming, and multi-agent-oriented programming are, first of all, in my case, very important from that point of view. So what was with this talk, I would like to start from my recent background mumbles that say things that I try to really a little bit be worried about. Worried about what? So, you know, every one of us is living in this cognitive era, in a sense. So AI did all this kind of great progress everywhere. Learning, machine learning is everywhere. And this kind of progress is leading to devise this kind of new era for software 2, software 2.0, in which you don't have to program, but just learning is everything that you need. So in a sense, there is a paper that we wrote with Rafael and the guy, Amal and the guys about, but is it still meaningful to talk about agent programming in that kind of cognitive era? It's a provocative question, of course, but the point is, at the end of the day, should we devise a new generation of agent architecture languages and even agent-oriented software engineering methodologies that foster a deeper integration with AI? I mean, and in particular, I was a little bit surprised. I mean, stumbled, or in literature, there's huge amount of work about cognitive architectures that have not been fully considered in our community. I mean, AMAS, the engineering mass community, even in the AMAS community. So the point was, is there any opportunity to think about some new synergy to devise a new generation of platform architectures, languages, of course, starting from the wonderful one that we have, in order to tackle this cognitive era? So the plan of the talk is, I mean, for me, all the things go back to the knowledge level as defined by the Allen Newell. And that was the premise to get into cognitive architectures. So you will have, 25 minutes, 20 minutes about revising, talking about knowledge level as I feel it and cognitive architectures, then to move on along some ideas that we are working on about developing further JaCaMo and Cartago in a way to go on to push towards this knowledge level and level of abstraction. So please interrupt me if you want, whenever you want, because really I would like to have, I love more interaction. It is strange to talk again here in the room alone, like in lectures, but I try to be reactive to for any question that you can have. So let's start from the newest knowledge level that I consider so important, because for me, this is the exact meaning of the agent level of abstraction. So, as you know, Allen Newell has been, a fundamental contributors for many, many things. Turing Award guys, he was the main guys in both AI and cognitive science, with Herbert Simon and colleagues, and he gave many, many contributions. But first of all, he was interested to develop a system-level research in cognitive science and AI to try to devise cognitive architecture that put together, that were able, in a way, that have twofold aims: modeling, understanding human intelligence on the one hand, and this is the more cognitive science perspective, but at the same time, defining blueprints for building general purpose, domain independent, intelligent agents. That is, for me, it's really absolutely interesting from an engineering point of view, from a software engineering point of view. So, and the knowledge level was introduced by Allen Newell 40 years ago at the end, and this concept created a strong debate in the community. So, now I will get some key concept that, but from my perspective, in a sense, I try to, of course, to consider the meaning, the general meaning from the papers and from the wonderful book. If you don't have read it, I would suggest this Unified Theories of Cognition. It is vintage maybe, but for me, it's really wonderful book. And so it is really a wonderful book, not only for cognitive scientists, not only for AI guys, but really for guys that are working on software engineering. Because it starts from describing a computing system. So a computer system, according to Newell, it could be described along multiple ways. And so we can have a stack of descriptions that are based on computer as behaving like a machine. And in all these levels, there is a meta model for all the levels, all the descriptions that we have, that in any case, there is some kind of medium which is processed by the machine. But the medium changes according to the level that we consider, according to the description that we consider. And each level is going to be characterized by some behavioral laws that can be used to predict the behavior of the system. So at any moment, the state of the system is about the configuration of its medium, and the behavioral laws can be used to predict the behavior of the system in the future. What prediction here is, as a general meaning, not only prediction in the future, but just to say explaining, which is a main point today, controlling the behavior, specifying the behavior, and so on. So the point is, this is a hierarchy of levels in which each higher level of description is both an abstraction and the specialization of the one below it. So, for instance, if I talk about electrical circuits, it's more abstract than the electronic device under the below. And at the same time, so it is abstracting from details that are concerning the devices, as we know, and that it is introducing new concepts that make it possible to define a new level of abstraction. At the same time, it is a specialization, because not every electronic device is going to create, it is going to be useful to build an electric circuits. The knowledge level is about the top level of these layers. So we talk about that we have a computer system, and the knowledge level is the way to describe and so also to specify a computer system which is characterized by a medium, which is the knowledge. It is above the program level system, abstracting, and here a key point is that it is abstracting from the internal processing and the internal representation of the system. So I can specify, understand, describe a knowledge level systems in spite of how it is then programmed. And then the law of behavior, this is quite well known in our community, but just to get back, the main law of behavior, it is a simple form of rationality. That is, given this way of describing the system, if the system wants to attain some goal G and knows that to do act A will lead to attaining G, then it will do A. So a very simple principle of rationality. And that was a way, from the point of view of Allen Newell, and we are talking about 30 years ago, or maybe a little bit more, to define the agent level. So for Newell, this is the agent level. So the agent as the knowledge level system. So we call agent the system at the knowledge level. So it is a level of abstraction. And so in this way, we find all the things that we typically talk about agents. So it is an embedded environment. It is embedded into an external environment with which it interacts with a possible set of actions. The behavior of the system is a sequence of actions taken to be taken in the environment, and the system has goals about how the environment should be. This is a description, again, description at that level of abstraction. And so internally, the system processes a medium called knowledge. So its body of knowledge is about the environment, the goal, and the actions, and the relation between them. And then the single law of behavior is that principle of rationality. So the system is going to take action to attain its goal using the knowledge that it has. By the way, this is a way in which Allen Newell is going to define intelligence. The intelligence is not about how much knowledge that you have from that point of view, but how much you are able to exploit the knowledge to achieve your goal. So if you don't have knowledge, you cannot be intelligent from that point of view. Anyway, so given this characterization of the agent level and knowledge level, we can refine. There is a refactoring also of the levels below, and so you'll talk about the symbol level, physical level. So the level under the knowledge level is what make it possible to create the knowledge level, and it is the symbol level, actual representation and information processing mechanism used by the system in order to reach its goal, given the knowledge it possesses. So it is a way to represent the knowledge level. And so this is the programming level in a way, approximating the knowledge level. Look here, as I get, there is, of course, there was a strong, as you may know, debate in literature about symbolic and not sub-symbolic and all the stuff. But here, the symbol level, it's not necessarily about logic-oriented approaches or logic-based or not symbolic, sub-symbolic. I mean, this is just a way to define, from my perspective, the way in which we are going to represent the knowledge in a level. Of course, you can decide not to have a representation, but as soon as that you have some kind of representation and laws changing this representation in a way that is going to produce knowledge, this is a symbol level. So moving on about this, one point that for me was triggering a little bit is underlying that when we talk then about knowledge, we are talking about the domain level, not the technical level. So here we have to be sure that we understand that agent level means talking about the semantics, the domain level of abstraction. So for me, here I find many things that concern also, for instance, directions or methodologies in software engineering when we talk about domain-driven design. So that at some level of abstraction, we want to have systems that are specified at the domain level. And moving on, just to say, well, these hierarchies and this discussion where we know that was put in a strong relationship with the other way of, or other framework, conceptual framework that were put in literature that are a reference for the agent community. For instance, the Dennett's intentional stance. The intentional stance of Dennett is really absolutely strongly related to the knowledge level. But in that case, the main difference is that Dennett typically was talking about intentional stance from an observer point of view. So how do I interpret or observe a system working? Instead, in the case of Newell, a point which is very important for me from an engineering point of view, for Newell, I mean, the knowledge level is something that could be used to drive also the design of the system, not only a way to interpret a possible behavior of the system. So, and this is related also to Pilichin's level, 3 levels in cognitive science, talking about semantic level, syntactic level, physical level, which is used to explain the behavior of cognitive systems. These two is absolutely, there was, and there still, I guess, still is strong debate about this interpretation, this proposal. I'm not going too much over there. Anyway, for me, it is important to say that when we talk about knowledge level, we are defining the agent level of abstraction. And Jennings, in 2 decades ago, in a well-known paper called Agent-Based Software Engineering, was extending the concept to go to the more social level. So identifying a way to define not only the knowledge level at the individual as focusing on the single agent, single system, but also extending the point at the social level. And so this is taken from the paper. We talk about agent organization, and in which we have agents and interaction and so on. And we know that we have absolutely models in our community and languages and platforms supporting this kind, and methodologies supporting social level. But again, here I would like to remark this. This is, of course, I don't know if it is an opinion of, but here when we talk about the social level, like the knowledge level, we are at the domain level, the semantic level. It is not about technical aspects. So it is not about the symbol level. It is about how we can specify a systems, and this specification should be strongly connected to the domain, to the business domain, I would say, in more software engineering terms that we want to model. It is not then agent and the social level, the agent organization, a technical concept. What we are going to see is that we have platforms that would like to make this jump, making it possible to keep the level of abstraction alive, moving from the knowledge level to the symbol level. Anyway, going on, I hope that you are hearing me. Yeah. Given this framework, this concept, why the knowledge level is useful from an engineering perspective. I mean, one key point for me is that this, as far as I know, these important concepts have been discussed so much in AI, in cognitive science, with different opinions, but not in software engineering. But for me, here, I would like to point out the engineering perspective. So why this is important from an engineering perspective? So the knowledge level is useful for designing systems whose internal working are yet not to be determined. So without having details of the actual internal processing. And so this is a clearly important point from the engineering point of view when we say, related to the point of specifying system at some level without considering how they are hiding or whatever, abstracting from the implementation. But we have a way to characterize, to describe the system at the proper level of abstraction. And it provides a way of stating something about the desired behavior and what we must incorporate. That means to specify systems. So they require the requisite knowledge and goals. So we can state properties of correctness or whatever, staying at that level. And a point that it is maybe, that is, in my opinion, not too much discussed, it is this level, it is ground to the domain semantic level. And as I told you, I see here strong connection with methodologies in software engineering, such as domain-driven design, that try to bridge the gap between the analysis, the business analysis of, and the design, identifying some ubiquitous languages and bounded contexts, so a way in which we are able to design also systems, but keeping the level of abstraction alive. So, and the level of abstraction, which is defined at the domain level, after doing a proper analysis. And so I see that there is a strong connection between a knowledge level, the agent level, which that means, and this way of trying to exploit that level to describe, to define things, but at the domain level. Anyway, so a point that was triggering me was, well, nowadays, if I'm in love, I'm working on agent programming and multi-agent programming and multi-agent oriented programming. What's the link with the knowledge level? Of course, the agent-oriented programming framework by Hyam Shoam was providing link, but if we reason about that, what we see is that, I mean, we can understand AOP and MAOP, the knowledge level, in the sense that languages and platforms are used then to construct systems at the symbol level that represent the agent, the knowledge system at the knowledge level. So we are going to represent, to still representing agents that are defined at the knowledge level, and our agent-oriented programming platforms make it possible to encode it, to develop it. But the key point here for me, it is that the agents are at the domain level. So, for instance, if we have a first-class concept in our language that support agent-oriented programming or multi-agent-oriented programming or multi-agent programming, for instance, about the goal or the belief, we should be, we should be aware that if we talk about goal and belief, there should be a clear semantics with the notion, with the same notion that we have at the knowledge level. And so it's not just so a matter of a syntax, but also of semantics. And the semantics should be related to the domain level. So the knowledge level was useful in literature, brought to the development of cognitive architectures, as we shared. So cognitive architecture actually started to be developed 40 years ago. And we have here, there is a recent paper, not recent, not so, yeah, 2020 papers that provide an overview about the cognitive architectures. There are many papers, different papers that provide this kind of review. It was mainly research topics developed in the context of cognitive science, but also in AI partially. But I would say that from my perspective, as far as my experience, there was not such a strong synergy between the community working on cognitive architectures and then the community interested, for instance, on agent-oriented programming languages and engineering multi-agent systems and so on. Of course, there are some key contributions that are a kind of joint. For instance, the PRS architecture is considered a cognitive architecture. This kind of research has actually twofold different objectives. One is about cognitive science, so modeling human cognitive behavior. The other one is defining a blueprint for building human-level agents, so flexible agents. So, and if we go, okay. Oh, sorry, maybe it was too. For here, I guess that there was a problem with the slide. So, Michael, can I check? Because actually, I don't see the slide.
Yes, yes, we also just see one yellow square.
Yeah, let me check if it is some problem of because it was a quite important slide. So,
if it is something about the platform, you can also transmit your screen. So
I see. Yes, I see that it's part of the. Yeah, it's a platform because in the PDF file it is there.
Okay, you can share your screen.
Okay, to share my screen.
It's near to the video camera. There is one button where there is your headphone. Then there is a camera, and then there is to share screen.
I see. Sorry. So you mean share your screen, right? So let me check. Okay, share this. Share. Do you see it? Maybe
it's take a while. Okay, I see.
Okay. So if it is okay for you, I'm going on with this.
Okay, it's fine.
Okay.
You can put full screen if you'd like.
Okay, and then if you have, I mean, just because I don't see no more the chat and whatever. So if you have, just tell me by your voice, by
yes. I keep watching here. We don't have any question in the chat so far. And if there is some impressive, Michael will tell us.
Something strange. Okay, thank you very much. So we said that cognitive architectures have been developed through so for 40 years now. And then, and we recognize, I mean, that there are here names that have been never discussed, I mean, appear too much in the AMOS community, for instance, but some yes. So, for instance, there is also PRS, of course, in between 1980 and 1990. But what's the point about cognitive architecture? What are cognitive architectures? So, in the knowledge level perspective, so a cognitive architecture is going to be that part of the cognitive level, of the symbol level, providing the fixed computational structures for creating the knowledge level agent system. And so the fixed computational structures. And the main research focus of these guys in cognitive architectures was about creating structure that support an integration of capabilities. So from learning, encoding, using knowledge to perform some tasks. So of course, any kind of cognitive architecture, since it's focused in performing tasks, it must include a way to also deal with decision making, with the interaction with the environment. So something which is quite normal for us, for the people working on agent-oriented programming and engineering maths, it is exactly a main point. So cognitive architecture is about this layer, fixed layer. And in fact, there is a kind of equation which is quite, the same from the agent point of view, that we say architecture plus knowledge is the behavior that has an agent. But again, an agent at the knowledge level of abstraction is going to be the result of the architecture, which is fixed and task independent, of course, and the knowledge of the agent, which is instead task dependent and grows through learning. So this is the main equation, I would say, of cognitive architectures. And learning modifies and adds knowledge, but it doesn't modify the architecture. So, which is fixed. The architecture provides the learning mechanisms that make it possible that define how knowledge changes. And so if we look about the prototypical structure of cognitive architecture that we have, that is shared by all the architectures that have been proposed, we see that the cognitive architectures are close cousins to computer architecture. So they have memories, processing and control components, way of representing data, input-output devices. But the main difference is that instead of needing to support general computation, they are focused to support the representation, acquisition, and use of knowledge to pursue goals, where the notion of knowledge should be understood at the knowledge level, that level. So we have, symbolic short-term memory, declarative long-term memory, mechanism for declarative learning, mechanism for procedural learning that are going to affect the procedural long-term memory, which is where there are the rules and so on, and then there is the process selecting the action and so on. And this is the typical prototypical cognitive architecture which is shared, and also our architecture, if I consider, for instance, BDI and PRRs, of course there are strong similarities between this architecture and this kind of prototypical cognitive architecture. This is a concrete example, for instance, SOAR. So SOAR has been and maybe is a main cognitive architecture, and it is the cognitive architecture developed in, as you know, developed in the context of cognitive science at the beginning by Newell and Laird and all the group to define in order to model the human behavior. But at the same time, it becomes a reference in order instead as a blueprint to build artificial intelligent, human level intelligent agents. So, and nowadays, SOAR, it has been used as a platform, as architecture for developing and implementing, agents, intelligent agents for concrete applications, and we can recognize the prototypical cognitive architecture with some specific approaches in order to manage, for instance, to realize, for instance, learning, such as chunking. It is based on some very important concepts, such as the problem space computational model, which was at the basis of the Newell and also Simon way of understanding, characterizing the behavior, the general behavior of agents, and so on. Anyway, it is not only about the structure that these kind of commonalities concern also the dynamics. Cognitive architecture dynamics is based on a process cycle, like in the case of computer architectures, but instead of having the classic von Neumann processing cycle, in which there is no knowledge search, here again, even the processing cycle is strongly based on the knowledge level. So it is enriched with knowledge level related stages to realize the principle of rationality. For instance, this one that you see is the one adopted by SOAR. And also here, if we have in mind the BDI reasoning cycle, for instance, in architecture such as AgentSpeak or JSON, we have strong similarities. Also over there is a reasoning cycle. In a way, also over there, we have a kind of knowledge search. I would say that here, the point about knowledge search and also the cycle is extended and larger in order to support that kind of, for instance, support for learning and other capabilities. Anyway, so a key point from my perspective of the cognitive architecture is about that they provide a blueprint for creating general autonomous agents, so able to solve not only a specific task, but able to solve and learn from a wide variety of problems using a wide variety of knowledge. So that was one of the main objectives of this kind of research, to achieve what they call human-level agents. And so a primary challenge over there is then setting up an architecture which is capable of coordinating the many capabilities, so integrating not only proactivity and reactivity, but we have to deal with learning, for instance, and then understanding how it is possible to put planning and so on. And so in literature, actually, cognitive architecture, we can recognize three main lines. So besides cognitive modeling, which is in cognitive science, we can, understand, we can see that there were development, there were contribution on the agent, about cognitive architectures able to support agent development or human level agent development. And the agent development, take for instance PRS was the goal was to support the development of AI agents that interact with dynamic environments, employing multiple AI techniques. But typically when we talk about cognitive architecture for agent development, agents are designed to deal then with a specific problems task, even if the cognitive architecture is general. When we talk about instead human level agents, such as the one which is supported by SOAR, we have that the goal is to have a cognitive architecture which is able to support the development of AI systems that support a broad range of behavior and cognitive capabilities. So the same agents can work on a wide variety of problems. So, and this is, for instance, a comparison, not a comparison, but just to have an idea about an example, typical example of agent development cognitive architecture, which is PRS. And on the other side, SOAR as a prototypical example of human level agent development, cognitive architecture for human level agent development. On PRS side, we have programmability as a focus, as a feature, which is not the case in the case of SOAR, in which over there the focus is more on generality, adaptability, and flexibility. In spite of that, so the second point of this first part, which is going to be finished, is so after the knowledge level, why cognitive architectures are useful from an engineering perspective. So from my point of view, this kind of, cognitive architectures are very important to reduce the effort for developing agent system as knowledge level system. They provide the proper level of abstraction, which is meant to be near to the domain level, and so the business level from an application's point of view. And then they can exploit an integration of multiple AI capabilities in order to that are not to be proposed, not to be written at the application level, but they are embedded in the cognitive architecture. And in the case of human level agents, over there is even more. The reuse is pushing at the extreme level in a way, because we can reuse the same agents across different tasks and problems, adapting through learning, for instance. So from an engineering perspective, this is going to push even further the idea of reuse. So the first point that I see, that mumbling, this kind of mumbling that I had, is that I think that in order to go on with research in engineering maths, agent-oriented programming, multi-agent programming, it would be really interesting to explore more synergies with cognitive architectures, as we saw. And so the idea is that fostering a new generation of AOP, MAP, and MAOP languages and platforms, starting from an existing one, but then based on cognitive architecture and knowledge level towards the definition of more general purpose integrated frameworks for building intelligent agents and multi-agent systems that include also high-level cognitive capabilities, but at the same time are for engineering systems. So where they can, there could be the focus that typically we have when we talk about programming and when we talk about software engineering. And so if it is okay for you, if you, I don't know if I was able to, I mean, if you to make me understand, so make it possible to understand some points about this first part. The final part of the talk would be, so given this mumbling, we worked recently to work on doing explorations that have been targeted to explore this idea of pushing the knowledge level further in the systems that on which we are working on. For instance, in my case, it is more related to in Carthago and JaCaMo in a way. So taking some properties of things that we saw that are important at the cognitive architecture level, such as in SOAR, and try to understand how this could be framed also in the case of, for instance, BDI. So if I have time still, I have time, guys, for going on, or?
Yes, okay. We have time. We have end of this section at 10. It's now 9:20, so we will have quite some time yet. Just make sure like we have some time at the end, like for some questions, some discussions. I suggest maybe around 20 minutes. You can yet speak for sure.
Yeah. So besides after this very broad part, I'm going to be more specific on some specific ideas that on which we are working on. The first is about the role of learning. So revising, getting back the role of learning, revisiting the role of learning in agent-oriented programming and all the stack, and introducing the idea of agent programming as a developmental learning process. The second one, it is quite new, so it is not in papers still, and it is how do we see bridging, I mean, A&A, the next version, let's say, of A&A and Carthago, pushing for the knowledge level. So all these things have been inspired by cognitive architectures and what you saw in the first part. So first of all, what does it mean, agent programming as a developmental learning process? So the idea is that if we consider learning in AOP, in MAOP, and in AOSI, there are a large amount of papers and contribution that typically in which the main focus is about applying existing machine learning techniques, for instance, reinforcement learning, to make the agent more adaptable at runtime. And actually, I was impressed by the fact that, for instance, SOAR, on the cognitive architecture, on the other hand, embed some mechanisms about learning, not only reinforcement learning, but also, declarative learning and so on, in the core of the architecture. So I was triggered to say, but what does it mean? What does it mean to put learning at the core in the BDI, architecture, at which level? And besides the BDI, the programming, what does it mean to put together that view, that mechanism with the programming of agents? And so the idea that was quite simple. It is, of course, an idea which is that has been put in many papers. So about, for instance, BDI. So if we see when we talk about BDI agents, we go from typically if we have JSON, for instance, or agent speak or whatever, but also if we have the other programming languages, typically the developer is going to fully design and fully program the agent. So I'm going to implement all the plans that the agent should have, and so on. So this is one extreme. On the other extreme, in this cognitive era, there are agents that are purely based on learning. So purely based on reinforcement learning, deep reinforcement learning, for instance, and you don't have to program at that level. So they are purely trained. So from an engineering point of view, from my perspective, I would like to, first of all, frame this segment at the proper level of abstraction, at the knowledge level of abstraction. So what does it mean that we are moving on this segment? And in particular, I would like, as an engineer, to choose what part of the agent should be, I would like to specify, I would like to program because I find it necessary to do it. And what part of the agent instead I understand that should be instead based on learning. So, and from that point of view, learning is going to be explored as a core enabling feature, not only at runtime, but also in the process of designing and developing your agents in order to be ready, in order to for doing the tasks. And so in order to understand these at the knowledge level, we try to get some inspiration also from human sciences and educational psychology. And over there, first of all, of course, there is the idea that learning is so important as a core domain-independent capability to achieve autonomy and adaptability. So in a sense, you cannot talk about autonomy and adaptability if you don't have the support for learning. And learning is a continuous incremental process, and there could be different kinds of methods and theories. And by the way, for instance, reinforcement learning and deep performance reinforcement learning could be more related to behaviorism. Instead, cognitive architecture could be based more on cognitivisms in order to understand which kind of learning we have. Anyway, so the idea was and is, in a way, rethinking agent development, taking inspiration to education in human science, so that instead of, if education, in a way, is the process of facilitating learning or the acquisition of knowledge, skills and values and beliefs and habits, so we can frame at the metaphor level that agent development, in order to have a high-level way of integrating, in a way, programming and learning, we can understand agent development as an education process in which you set up an agent with first design and programmed part, and then during the development stage, you grow up your agent through an education-like process based on learning techniques. If you get this kind of metaphor, so you are able to revise, to rethink the agent development as a kind of education process in which you have the objective of the education process is what the agent is meant to learn. You have some specific, a bunch of techniques and methods, which learning method, environment, and tools you are going to create in order to support this learning. You have the assessment, which is the validation of all these, but also you have monitoring the runtime performance of the agent in order to understand if the education process is good, and so on. So the idea is that to explore this kind of metaphor in order to understand, to devise a new way of understanding the agent development process. So in this process, anyway, you have this kind of hard part, which is something which is not learned at the beginning, and then the soft part, which is instead what is going to be grown up by the education process. So there was the first ideas was put, and experiments in JSON was put in a paper in Amos in 2019, and then more recently last year, I wrote there is a paper in Blue Sky in Amos, which is trying to put some foundation from the conceptual point of view of these kind of things. I called it developmental learning for intelligent agents, because I took strong inspiration from research theories and studies about developmental learning in children. So the paper is go to the children, rethinking intelligent agent design programming in a developmental learning perspective, with the idea to say, look, over there could be some points that are interesting about how you grew up. I mean, how children do in creating, in learning things from scratch in a way. And this could be inspiring, according, for instance, to the theory, to be applied also from the agent point of view. So, an intriguing point for me is that in that kind of theories, causal learning and reasoning is a fundamental concept that is founding the core behavior of, children and from our point of view of the cognitive architecture. So one important point would be why extending our cognitive architecture to have a first-class support for causal learning and reasoning, because this is going to be fundamental in order to support developmental learning. And as far as I know, there are no strong work discussing these in the community. And I would be really interested to develop these, because this is going to be a core level mechanism that is going to be used in order to support the developmental learning. And of course, given that kind of exploration, there is a large set of open issues. This is just besides first experiments, it is just open issues. So only questions and open issues to understand the development, characterize the education process cycle. We're thinking also to what does it mean when you have these perspective. What are the properties? How do you characterize the property of the systems in terms of modularity, extensibility, reusability, and so on? So there are, if you are interested, there are some points in the papers that are about this. A main point is about, okay, we are discussing not only about agents, but an interesting perspective is about a multi-agent system perspective, of course, and a MAOP perspective. So what does it mean to set up an education process for a multi-agent system, for an agent organization? Still, it is just a metaphor, because this means I want to engineer a complex software system in terms of a multi-agent system, but I understand that I want to integrate some parts that are engineered and other parts that instead are learned. And so the point that I try to put here. That was the first direction that we are working on in these years. The second one, if you don't have questions, I'm going to focus these two. This is more practical, absolutely more related to concrete implementation stuff, something that is going to be for which we are working on from the implementation point of view. It is about reflecting about how to put A&A and Carthago at the knowledge level. So briefly about A&A, what does it mean? So agents and artifacts, we introduced this kind of conceptual model to understand multi-agent systems, in which basically inspired by also the human level of abstraction, you don't have only agents, but environment could be a first class, could play a role as a first class part of the system that could support your agent. So the idea is that when you design a multi-agent system according to A&A, and then according also to JaCaMo and so on, multi-agent oriented programming, you don't have to think only about agents. You can design also the glue between agents, not only in terms of communication protocols, but designing first-class abstraction in order to have to wrap to design the environment between the agents. So this is a picture in which you can see that there are agents working at the same time. They design proper tools in order to support their work. They do not only communicate, but they are also create dynamically and use tools, artifacts in order to work. That was the basic idea. And so artifacts over there are first-class abstraction to represent design modularized environment at the agent level of abstraction. So the point is, an artifact should be at the same level of abstraction of the agent, of course, with a different metamodel, with a different characterization. So if we say that agents are proactive, reactive, goal-driven, so on, artifacts instead, we said they are more providing some functionality, more like a piece of environment. So they are fundamentally different from the conceptual point of view. So and this is a snippet from the book in which we had some kind of meta model in which the artifacts is characterized by some observable properties, operations, and then also signals. And these are mapped on the agent side. So when an agent do an action corresponds to executing an operation of an artifact, and then observable property on the artifact side are mapped into beliefs of the agency if the agent is observing the artifacts, and so on. So, and we have also Cartago. Cartago is a very simple framework, for implementing artifact-based environments in Java. And we have a simple Java API in order to write down, to implement artifacts that are used by agents. And so, for instance, here you see a count artifact that has a single observable property and there's a single operation inc to implement the property and so on. Cartago is independent from the specific agent dimension, but the point is it has sense only if you integrate it with the other dimensions. So in particular, the agent dimension and also the organization dimension, for instance, in the multi-agent oriented programming perspective. And JaCaMo is, as you may know, a platform putting together these pieces. So it is possible for agents to work, to communicate directly, but also to create, to share artifacts and to act on them with this kind of mapping between actions and operations and so on. So given these, the main question is, what does it mean, the knowledge level for the environment and then for A&A? Because we have clarified what does it mean for the agent level. So agent level and knowledge level are the same level. So what does it imply for environment? And is it A&A and Cartago then at the knowledge level? Because the point is, since the artifacts are the same level, conceptual level of agents, so they must be understood at the knowledge level. Cartago is what make it possible to have A&A, so it is the symbol level. So a couple of reflection here. So environment and artifacts at the knowledge level means that we want to represent at the knowledge level the task environment that has an explicit domain level semantics. So it means that artifacts should be used as a concept in order to model the domain level semantics, the domain that agents are working with. And so they should be the source of knowledge for agents to attain their goal. And we have the meta model is about these sources is modeled in terms of observable properties and events. But the point is that observable properties and events should be understood at the domain level of abstraction, so with explicit semantics. And they are also the source of actions that agents can do for attaining their goals. And again, in terms of operation. But that again, that operation should be understood and explicitly characterized at the domain level of abstraction and semantics. And so the first point is then observable properties, events, operation must be understood, must have a well-defined domain level semantics. The second point is that typically when we talk about the environment, task environment at the knowledge level, they are not monolithic. They could be open structured systems of interrelated elements. So at the domain level, this means that we have environment that could be dynamic composition and aggregation of multiple elements. And these elements, these pieces that for us as artifacts are typically related in a way. So, and the relationship among these elements that we call artifacts should be part of the knowledge that agents should be able to understand, to reason about. So the point is, in A&A and Cartago, A&A already support the idea of modularizing environment in terms of dynamic set of artifacts, but we need to have a way to represent the relationship between artifacts. And relationships can be modeled then as predefined type of observable properties at the domain level of abstraction. Actually, at the beginning, so far, we have used the linking process, the linking concept in order to do this, but it is not really at that level of abstraction. Linking, at the end of the day, in Cartago and A was more introduced from an implementation level perspective, from a way to compose things, but not at the proper knowledge level of abstraction. So the idea is that we need to introduce the possibility to directly model relationship among artifacts as a predefined type of observable property grounded at the domain level. So the point is putting the things together, what's going to be in the next version of A&N Cartago. So we want to extend the A&D metamodel with the relationships as predefined type of observable property. And then a key point is adhering explicitly to the knowledge level of abstraction. So it means that we are going to, we see that the knowledge graphs are, from our perspective, a very good way to define the semantics of artifact at the knowledge level of abstraction. What does it mean? Here, sorry for sketching it by hand, but I did not have time to report in a different format. So on the left, you see a typical way to represent artifacts in which to have artifacts. So we have artifacts representing, think about the smart environment, you have the light, an artifact representing a button, an artifact representing a room, an artifact representing also a building. And for instance, the light could be the status off or on, and I can switch on and switch off the light by means of two operations, on, off. The button could be pressed or not, and the room is going to be locked or not. On the right, you see a sketch of the knowledge graph that we would like to have at the knowledge level, so that agents at the knowledge level are capable of perceiving and working on the environment using the knowledge level that you see on the right side, which is implemented, which is raised, which is realized by the symbol structure of artifacts on the left side. So if you see in the knowledge graph, I can represent using RDF here. I mean, a way to say that we have a building in which contains a room, and the rooms contains a light and the button is connected to the light, and so on. So we recast to the classic semantic web, I mean, to the class way to represent semantics that we have, for instance, in using semantic web technologies. So that is going to be a way to represent, from our perspective, knowledge level also for the environment. So this means extending Cartago to support also relationships, and extending Cartago also to have a direct support for working with artifact knowledge graph. Each artifact define a knowledge graph. The set of all artifacts are defining a distributed knowledge graph. And we are going to use RDF as a standard language to represent the knowledge graph. And this allows you then to embed in the platform also the possibility to do semantic level queries exploiting the artifact's knowledge graph. So in a way to have, for instance, using SparkQL. Of course, this is going to be connected with the agent organization dimensions. And over there, then, we are going to be to see the fruitful integration with all the large existing work that is already integrated agents with semantic support. For instance, from JASDL, I'm thinking about JSON, but it is not only about JSON, but of course we have the literature about how semantic technologies have been integrated in already, and also a description logic anyway, into agent-oriented programming and also ontology reasoning. So the idea is that to support this level also for the environment side. And this new move is absolutely strongly related with existing work such as hypermedia mass. In fact, it has been also inspired by working also with Andre and so on, and which is focused on a crossover between autonomous agents and semantic web. And there is the Yggdrasil platform. So these are, I mean, moving in the same directions in a way, of course, at different levels, in the sense that the extension of A&N Cartago is not necessarily related to support hypermedia mass. Hypermedia mass, I would see hypermedia mass on top of it. But this is just a way for us with A&A and Cartago at the knowledge level to support really the knowledge level when we talk about agents that are at the knowledge level. And so to wrap up, I hope that some point could be clear. Anyway, in this talk, I would have, my point was to go back on concept about knowledge level and how they be used to shape cognitive architectures, and how all these have values from an engineering perspective, not only from an AI perspective. And then the idea is that we can find new synergy synergies with existing architectural languages that we have and platform for AOP, MAP, and MAOP and methodologies. So integrating, exploring the integration of concepts that come from cognitive architectures into our platforms. So in order to inspire new generation of cognitive architectures, languages, and tools for developing next generation of agent-based systems, in which a key point is the level of abstraction that you use. And this is going to affect also the tool that we can exploit in order to design, in order to support the process of developing this kind of systems. And so I think that it's the end of the talk. Thank you for listening me. I hope that I'm going to stop sharing. Okay. So
thank you. Thank you, Alessandro, for the great presentation. I love it. Let's see if there is some questions. Who have some question in the chat? Please feel free to raise the hands or write to the chat. Se alguém tem alguma questão aqui no chat, fica à vontade para levantar a mão, escrever aqui no chat. O Michael talvez pode ver se tem alguém pessoalmente ali. Já temos alguém? Temos o João?
Hello,
João, feel free.
Are you listening?
Yes. Hello, Jomi. Hi.
Hello, Alessandro. It's a huge pleasure to see you and to listen to you today. Thank you very much for the very inspiring talk. And I love your talk. It's very, very nice. Thank you very much for the talk.
You,
and thank you also for sharing your personal perspective. That's a very good opportunity to share personal perspectives, and so thank you very much. And I have several questions, but I will try to select one for you. And it's just your opinion, or if you already see something related to learning to act. Because as far, I'm not an expert in machine learning, but as far as I know, most of the techniques are based on learning to classify, learning to predict something, or I don't know. But there is very few approaches in learning, machine learning, for learning to act. Of course, we have reinforcement learning, that's learning to act, but it's quite difficult to classify this technique as a cognitive-based technique. Yeah. So it's not cognitive in some sense, and I guess it's a bit out of the box you presented in your talk, in the sense that we are trying to use cognitive agent architecture. So the question is, do you know something or have some ideas about how an agent can learn to act in a cognitive perspective? Thank you very much again, Alessandro.
Well, thanks. I mean, this is, I'm not an expert of machine learning, and so I know I was in love with reinforcement learning, but also I tried to learning it because it was so impressive, the kind of things that they are able to do with also deep learning. But at the end of the day, I fully see the point that you said. Reinforcement learning, from my perspective, is that learning instinctively what to do, but without knowing why to do it. So, of course, guys, I'm not an expert of that, but I see the fundamental point here about that. The why is the key point. So I'm thrilled to consider those learning to act at the cognitive level approaches that make it possible to understand why things. And so here we go forward or back to Judea Pearl and causal learning and causal reasoning. So for me, the key, and in the framework that Judea and all the guys that are working on it is going to provide this kind of 3 layers of in which you can understand cause and effect, And I guess that this is a very promising but literature and world to consider. Also, if you see, for instance, what is happening in humans. I mean, I was talking about the inspiration from the literature exploring how children learn, and over there, over there they do not. It is clear that it is not only about reinforcement learning. This is just a small part of the story. But of course, it is important. But it is just a small part of the story. And the other part, instead, apparently, is strongly oriented to a causal learning. So I'm not sure, but I would say that if I had to bet, so to say an approach that is interesting to put inside the cognitive architecture that we have to support this kind of more cognitive learning would be causal learning. But, you know, I'm just mumbling because I did not have the opportunity still to go on and to explore also more technically, more formally, more everything about these seminal ideas. But I fully see your point, Jomi. I agree. I fully agree with you. So for me, but you know, in literature, there is strong debate. There is this paper by Doina, it seems to me, well, reward is enough. They say reward is enough. And I say, from my perspective, it's not true that the reward is enough. From an engineering perspective, it is not true at all that the reward is enough. I don't want to know why things, and the why is missing. I get the reward. I understand that I have to improve, but I don't know why. Of course, there is lots of literature, I guess, recently trying to put together things. But for me, reward is not enough.
Okay.
Are you there, guys? Okay.
Yes. I'm here. Just listening if there is some other question. Let's see with Michael if there is some other one in presence. I'm monitoring the chat and also the YouTube channel.
I don't know, Jomi, if I answered your question or if it was.
By Zoom? No, yeah, very, very. We are just chatting or discussing. I don't expect an answer for the question. I guess it's a very open question to be discussed. So, yes, it's a very good comment on that.
Please come here in Cesena, let's say 3 months or 6 months that we can talk together about this.
I'm planning so. That's a huge desire. It's not a commitment yet, but. So I have another question if no one else.
Yes, I have one question too, but you can ask first.
It's a very simple question. Do you have an idea about who is the teacher in this education process for the agents? Because in human education, teachers are very important.
Yeah.
Even parents or other guys. But do you have an idea about what is the counterpart of teachers in this idea of educational process for agents? Are the teachers humans, for instance, or are they environment, or I don't know?
If you see, that's a funny point because that kind of literature we are working on with children, I mean, doing computational things and coding. And over there, I had the opportunity to get to explore Papert, Seymour Papert, and constructivism, and in which the idea about also learning is that the teacher there should not be an instructional way to, if you want to allow kids to get into the point, do not have you had to set up some learning environment that make it possible for the kids to learning autonomously the things, and only exploring and understanding things into a proper learning environment, which could include also the teacher, but the teacher should not be too much invasive, It is the only way that make it possible that the kids and the children and also the people is really learning. And this was inspired for me. It is a very important point also for in the agent case. So I'm not expecting in the future to say that, of course, it is important to have the teacher that could be a human, or that could be, I'm expecting at the same time that we are going to design proper environments that are going to be learning environment, simulating things, but that make it possible for the agents to explore, like in the case of reinforcement learning, but understanding why the things. So in an environment in which there is an explicit description of, for instance, of cause and effect, that make it possible for agents to understand what they are going to do and why they, in a way, they could be motivated to do it. So, I see the opportunity to have a way to have teachers such as other agents or human, but at the same time, the fundamental importance of having a proper learning environment as a first-class layer in which agents are capable of grow up by experimenting, by understanding things, trying things, and so on.
Okay. Is there any other question? No?
No.
Okay, so I'm going to ask my question. It's a very simple one. Today, when we develop a multidimensional multi-agent system with environment, organization, agent, we already have, like, as a program, to know at least 3 languages if we use JaCaMo. Do you believe we're going to have a number 4 language, for example, to specify the acknowledgement level in the future, like with the proper dedicated syntax, semantics, so the developer is going to need to learn another language?
For me, I don't think so. I think that, I would be, because, that even JSON could be the symbol level. That level that make it possible to support as it is in a way, the knowledge level. But what I'm expecting is that we are going to extend our platform in order to have, of course, what has been already thought from guys that are working on semantics and also ontology, so that in a way, when we design and specify an agent, we see the agent not as a technical stuff and technical abstraction that make it possible to have some kind of behavior, but really we push to have some strong support to have to bridge the gap between the symbol layer and the knowledge level layer. So in a way to have a support, so not new languages but refining the existing one in order to reduce the gap between for the knowledge level that we want. It is not only about model-driven design, because in a sense one could say, well, is it model-driven engineering but pushing at runtime and pushing in a way in which we stick, we support the flavor of programming, but at the knowledge level of abstraction. So, Michael, I don't know, I don't have a clear answer, but at the same time, I don't see the need of having further languages on top, but refining the agent languages that we have in order to adhere more properly, to support more properly the knowledge level of abstraction, instead of going to simple programming languages. So, some times ago, I was committed to say, well, look, I would like JSON to be more similar to Java. I don't know. For me, it's not that the problem. No more. Because JSON, it should be at another level of abstraction, and it should support the knowledge level of abstraction. It is not about it's, for me, it's not more to say, I would like to have an agent language which is more similar to typical programming languages that are used because for me, the mission of agents is to be projected to the knowledge level. So I'm not scared if JSON or AAPL or Goal are going to have a way, a syntax or whatever, which is going to be to support more strictly the knowledge level, even if it is going to be quite far from the machine, from the implementation level. This is good because it should be away from that. So the more we support first-class abstraction that make it possible to have a shorter distance with knowledge level, better it is. So sorry, I'm stopping. I see that it is 3 p.m. So here 3 p.m. I guess 10 p.m. in your case, right?
Yes, it is 10 a.m. Sorry. Thank you, Alessandro. Let's see if there is some other questions. Some final one. If there is not any, one final check here. In the YouTube, nothing. Chat, also nothing.
No questions anymore here.
Okay.
Yes.
So we thank again Professor Alessandro for accepting our invitation, for coming to the result.
I really hope that was a little bit useful for you in the real.
Yes, for sure it was.
Yeah.
Okay. Thanks a lot for this invitation. I really.
Alessandro, thank you very much.
Have a great day there, Alessandro.
Yeah. Good luck for the wonderful WASAC. So.
Thank you.
Bye.
Thank you. Bye.
Bye.
Bye, guys.
Vamos tomar um café. Depois voltamos para o demo. Não sei se alguém está assistindo de fora. Às 10h30 a gente retorna para a sessão técnica 2 com os demos e um full paper também. Aqui,
Até mais, pessoal.
Deixa eu ver quem tem demo, que é o Pedro, o Vitor e o pessoal do Plantar. A gente vai tentar organizando aqui durante o coffee break as coisas. Pessoal,